Here's a scenario you've probably lived through, or you're about to. A 7-year-old SUV pulls into a detail shop. The body paint is fine, the wheels are fine, but the fender flares, wheel arches, windshield cowl, and mirror housings have all turned the color of a faded gravestone. Chalky, gray, defeated. The estimate comes back at $385 for a trim restoration package, ceramic-coated, 90-day guarantee. 30 days later, the gray is creeping back. 60 days later, the owner is booking another appointment. That number isn't an outlier. According to IBISWorld, the U.S. car wash and auto detailing industry generated roughly $18.7 billion in 2025. A meaningful slice of that revenue comes from one repeated procedure, making faded plastic look black again for about a month at a time on a recurring basis for the life of the vehicle. Now here's the strange part. The actual fix, the one that works on a molecular level, that costs about $1.50, that has been quietly documented on car forums since around 2010, is sitting in your bathroom medicine cabinet right now. Unpatented, unmarketed. It works because of basic chemistry anyone with a high school education can understand. Welcome back to Oracle Prime. Today we are not doing a hack video. We are doing forensics. We will put a piece of dead plastic under a magnifying glass, trace exactly what failed at the molecular level, examine why every commercial product on the shelf is engineered to fail predictably, and identify the unpatentable compound that speaks the same chemical language as your bumper. We will also identify the one place this technique destroys parts of your car if you're careless. Stay with me. Part 1. The crime scene. What faded trim actually is. Pull a magnifying glass to the chalky gray of a faded bumper cover, and you are not looking at dirt or a stain. You are looking at a crime scene. Modern automotive trim is overwhelmingly thermoplastic polyolefin, or TPO, a blend of polypropylene and a small percentage of EPDM rubber. It is tough, lightweight, cheap to mold, and absorbs minor impacts without cracking. That is why bumper covers, fender flares, mirror housings, and wheel arch trim across virtually every major automaker since the late 1980s are made from some variation of this material. But TPO has one fatal weakness: ultraviolet radiation. UV photons carry just enough energy to break the carbon-hydrogen and carbon-carbon bonds that hold long polymer chains together. When those bonds rupture, free radicals form and react instantly with atmospheric oxygen, a process called photo-oxidation, snipping the chains into shorter and shorter fragments. Meanwhile, the small additive molecules injected during manufacturing, plasticizers, antioxidants, carbon black dispersants, slowly leach out and evaporate. After enough years of sun exposure, what remains on the outermost surface is a thin, porous, brittle, dehydrated layer of dead polymer fragments, a corpse layer. Healthy polymer absorbs light coherently. The carbon black pigment soaks up incoming photons, and your eye reads the surface as deep, saturated black. Dead polymer is full of microscopic voids and exposed crystal edges. Light scatters in every direction, and your eye reads scattered light as flat, chalky gray. Here's the part that matters. The plastic underneath is still there. The carbon black pigment is still there. The color is not gone. It is buried under a few hundred microns of molecular wreckage. A 2024 study archived through the U.S. National Library of Medicine used FTIR depth profiling, a chemical CAT scan of the plastic, to confirm what most car enthusiasts already suspected. The damage is concentrated in a thin surface layer, just a few hundred microns deep. The bulk of the plastic underneath is structurally fine. That is the first piece of evidence in our forensic case. The fade is not a permanent color change. It is a corpse layer, and a corpse layer can be removed. Part 2. Why the commercial stuff fails. Before we attack the detailing industry, let's give them their fair due first. Commercial trim restores exist for legitimate reasons. Walk into any auto parts store and you'll see Meguiar's, Chemical Guys, Solution Finish, Cerakote Trim Coat, ranging from $15 to $30 a bottle. The better products in that lineup, Solution Finish in particular, which uses a dye and sealant chemistry, produce results that hold up for several months on properly prepped plastic. Detailers reach for these bottles because they are fast, predictable, and give the customer immediate visual gratification. In a working detail shop, where labor time is the largest cost on the invoice, a bottle that takes 90 seconds per panel is worth its margin. There is no conspiracy on the shelf. The shelf reflects an economic structure. Now here's what most of those products actually do. The typical $15 to $20 trim dressing is built around polydimethylsiloxane, silicone oil, a long, slippery, optically clear molecule that sits on top of the dead polymer layer. Silicone fills the microscopic voids well enough to reflect light coherently for a few days, which is why your trim looks dark and almost wet right after application. But silicone has no chemical affinity for polypropylene. It is sitting on top, like wax on a countertop. When the rain comes, or worse, an automatic tunnel wash with hot detergent, that silicone sheets right off into the storm drain. Some research suggests that as silicone breaks down under continued UV exposure, certain byproducts can accelerate further oxidation of the plastic underneath. So you may be paying for a temporary fix that makes the underlying problem slightly worse with every application. But here's the part that matters most. There is no villain. There is no boardroom of executives plotting to keep a $1 fix away from you. What there is a rational economic structure that produces this exact outcome. Mineral oil cannot be patented as a trim restorer, so no company can build a defensible product around it. It generates no recurring revenue. One bottle lasts the average car owner for years. It cannot pay slotting fees on the shelves at AutoZone or O'Reilly. It has no marketing department, no influencer budget, no 30-second YouTube ad. So it sits in the digestive health aisle of a pharmacy, completely invisible to the entire automotive ecosystem, while a $30 nano-ceramic graphene-infused trim coating gets a full end cap and a sponsored review on every detailing channel on the platform. That is not malice. That is market structure. Unpatentable products do not have marketing champions. That is the second piece of evidence in our forensic case. Part 3. The molecular family tree. Now here's where the chemistry gets interesting. Polypropylene is a long chain of carbon and hydrogen atoms in a saturated aliphatic structure. No oxygen in the backbone, no nitrogen, no aromatic rings, just carbon, hydrogen, repeating thousands of times in an orderly chain. Mineral oil, the clear, odorless liquid sold in the laxative aisle of every pharmacy, USP grade, food grade, costing about $1.50 for a bottle that lasts years, is a mixture of higher alkanes. Translation: it is also a saturated aliphatic hydrocarbon, a smaller, simpler, liquid cousin of the same molecular family. In chemistry, there is a foundational principle called like dissolves like. Compounds with similar polarity and structure have a chemical affinity for each other. They mix willingly. They penetrate each other. Compounds with dissimilar structures repel, water and oil, salt and gasoline. They do not get along at the molecular level. Mineral oil and polypropylene are not strangers. They are close molecular relatives. When you apply mineral oil to dead, oxidized, porous polypropylene, it does not sit on top the way silicone does. Capillary action, the same physical force that pulls water up the inside of a paper towel, draws the oil down into the open pore network that years of UV damage have carved into the plastic. Once inside, The oil molecules surround the surviving carbon black pigment particles still embedded in the bulk plastic and restore their ability to absorb light coherently. The oil fills the voids that were scattering light and forces the surface to behave optically like solid, intact material again. The plastic does not just look black again. It optically becomes black again, from the inside out, through molecular infiltration rather than surface coating. This is the reveal. But before you start squeezing mineral oil onto your bumper, there is one preparatory step that 90% of YouTube tutorials skip entirely. Skipping it is the single biggest reason most do-it-yourself attempts fail within a week. Part 4. The debridement step. Why prep is the whole game. In emergency medicine, you cannot dress a wound that still has dead tissue inside it. The bandage will trap bacteria. The healing tissue underneath cannot make contact with the dressing. You have to debride first, physically remove the dead material before any treatment can reach living substrate. Plastic restoration follows the same logic. Mineral oil cannot infiltrate a surface still coated in residue. Old silicone trim dressings, road grime, brake dust, polish wax, and that thin layer of oxidized polymer fragments we identified in Part 1. As long as that residue is present, the oil cannot reach the open pore network underneath. It will smear around on top, look great for an afternoon, and rinse off the next time it rains. The right tool for this job is 70% isopropyl alcohol, about $2 at any pharmacy, the same first aid alcohol your grandmother kept for cuts and scrapes. Reach for the 70% bottle, not 91 or 99. The 30% water content slows the evaporation rate measurably, giving the alcohol a few extra seconds to actually loosen and dissolve residue before it flashes off the surface. If all you have is 91, you can still make it work. Just apply more and re-wet the cloth more often. Soak a clean microfiber cloth, not paper towels, those shed fibers, and scrub the trim aggressively. Within 10 seconds, you will see something striking. The cloth turns brown and gray almost immediately. That discoloration is the corpse layer transferring physically off the plastic and onto your towel. Years of accumulated dead polymer and old silicone residue coming off in real time. Keep working until the cloth comes back clean against fresh plastic. On a heavily faded bumper, this can take 3 or 4 passes with a freshly soaked section of cloth. Then let the trim flash dry for about 30 seconds. What you are left with is bare, porous, prepared substrate, a clean canvas. Now, and only now, does the mineral oil do what we said it would do. Part 5. Application. 2 minutes, $2. Take a few drops of mineral oil on a foam applicator pad or a fresh microfiber cloth. You do not need much. A bottle that costs $1.50 will treat the entire trim package on a mid-size SUV with plenty left over. Work the oil into the trim with firm, even pressure. Cover the panel completely. Do not flood it. Watch the color return in real time. Not in 5 minutes, not in 10. In about 30 seconds, the chalky gray darkens, deepens, and resolves into a factory-correct satin black. The transformation looks almost like a chemical reveal, because it is one. Once you have covered the panel, take a clean, dry microfiber cloth and aggressively buff off any excess oil sitting on the surface. This step is critical. You do not want a wet, greasy, dust magnet finish. That will collect every speck of pollen and brake dust within a 100-yard radius. You want a dry touch satin sheen. The oil should be in the plastic, not on it. When you run a finger across the trim, your finger should come away clean. Done correctly, this restoration holds for roughly 4 to 8 weeks before fading creeps back in. The exact duration depends on 3 variables: climate, wash frequency, and severity of the original fade. When the appearance starts to dull, you reapply. Total cost per application, under 50 cents. Total time, under 20 minutes for a full vehicle. Compare that to the alternative. A single visit to a detail shop runs $150 to $400. A bottle of premium ceramic trim coating runs $50 to $80 and requires careful surface prep virtually identical to what we just walked through. The mineral oil method is not, despite what some YouTube titles claim, permanent, but it is economically permanent. You are not going to outlive a $2 bottle of mineral oil at this rate of consumption. Part 6. The EPDM trap, where this goes catastrophically wrong. Now we have to talk about the part almost nobody on YouTube mentions, because it is the part that gets the careless into expensive trouble. The same chemical affinity that makes mineral oil restore polypropylene perfectly makes it lethal to a different polymer sitting just inches away on every modern vehicle: EPDM rubber. Ethylene propylene diene monomer. The synthetic rubber used for almost every weather seal on a modern car. Door seals, window molding, sunroof gaskets, hood seals, trunk seals. It looks superficially similar to plastic trim, black, slightly textured, sitting right next to the bumper or door panel. It is not the same material at all. EPDM has a saturated polymer backbone that, while excellent at resisting weather, ozone, and UV, is highly susceptible to petroleum-based hydrocarbons. Documented in peer-reviewed research published in the Journal of Polymer Research, EPDM samples exposed to mineral oils absorb the oil into their polymer matrix and physically swell, sometimes by 50 to 100% of original volume. In practical terms, you splash mineral oil onto your door seal. The rubber starts absorbing it immediately. Over 24 to 72 hours, the seal swells, distorts, and softens. Cross-link density drops. The seal stops sealing. You end up with wind noise on the highway, water leaks in heavy rain, and a weather stripping replacement bill of $200 to $600 per door. This damage is largely irreversible. So when you apply this technique, work with surgical precision. Before you open the bottle, take a roll of basic blue painter's tape and mask off every rubber seal adjacent to plastic trim: door seals, window molding, sunroof gasket, trunk weather stripping. Apply the oil only to hard plastic: bumper covers, fender flares, mirror housings, cowl panels, wheel arch trim. Stay completely off the rubber. There is no second chance on this one. This is the line between a free fix and a $1,000 mistake. Part 7. Heavy artillery. Boiled linseed oil for severe cases. If you are dealing with extreme degradation, a desert truck baking in direct sun for a decade, a farm vehicle gone past chalky and into faintly white, plastic so brittle the surface flakes when you press a fingernail into it, mineral oil alone may not penetrate deep enough or hold long enough to be worth the effort. This is where a technique woodworkers and traditional craftsmen have used for over a century earns its place: boiled linseed oil. About $8 to $10 for a quart at any hardware store, in the paint aisle. Unlike mineral oil, which is a non-drying oil, boiled linseed oil is what chemists call a drying oil. Through oxidative polymerization, the triglycerides and unsaturated fatty acids in linseed oil react with atmospheric oxygen and slowly cross-link into a hard, durable, water-resistant film. The same chemistry behind oil-based wood finishes and the oil paintings that have survived for 500 years. For severe trim restoration, the proven recipe, documented on the R3V Limited BMW E30 forum and on Ford Truck Enthusiast since around 2014, is 1 part boiled linseed oil mixed with 1 part mineral spirits in a glass jar. The mineral spirits acts as a temporary carrier solvent, briefly softening the surface of the plastic so the larger linseed oil molecules can penetrate more deeply than they could alone. The mineral spirits then evaporates over a few hours. What remains slowly polymerizes over 24 to 48 hours into a hardened, bonded layer that survives car washes, rain, and seasonal weather in a way mineral oil simply cannot. Forum users on R3V Limited have documented results lasting 12 to 18 months on heavily faded trim panels of older vehicles. Not permanent, but an order of magnitude longer than commercial silicone dressings. 2 warnings, both serious. First, the EPDM rule from Part 6 still applies in full. Boiled linseed oil and mineral spirits are both petroleum adjacent, and they damage rubber seals just like mineral oil. Tape off every gasket and weather strip with the same surgical care. Second, and this one is genuinely dangerous, linseed oil cures through an exothermic chemical reaction. It generates real heat as it polymerizes. Rags soaked in linseed oil and crumpled in a trash can have caused thousands of documented house fires through spontaneous combustion. The U.S. National Fire Protection Association lists oil-soaked rags as a recognized fire cause. When you finish, do not crumple your rags. Lay them flat outdoors, fully spread on concrete or gravel until completely dry, usually a day or two. Or submerge them immediately in a sealed metal can full of water. People have lost their houses to this. Take it seriously. Part 8. Honest limitations. What this will not fix. Before you walk away thinking this technique solves every plastic problem on a car, let's be straight about where this method stops working. First, this is cosmetic restoration, not structural repair. Mineral oil and linseed oil restore the optical appearance of trim that is structurally still intact. They do not stop UV degradation from continuing underneath. The surface will keep oxidizing, just at a slightly slower rate. This buys you years, not centuries. Second, if your trim is already cracked, brittle to the point of crumbling, delaminating, or has visible chunks missing, no amount of oil is bringing it back. That is replacement part territory. Know the difference between a fade and a structural failure before you start. Third, in extreme climates, Phoenix summer, equatorial latitudes, salt spray coastal environments, you will need to reapply more frequently than the 4 to 8 week baseline, maybe every 3 to 4 weeks. The technique still works, it just demands a higher cadence. Fourth, if you have recently waxed or ceramic coated the surrounding paint, mineral oil that creeps onto adjacent body panels can disturb those coatings. The fix is masking. Tape the edges before you apply. Fifth, if your trim is heavily textured, like the deep grain plastic on truck fender flares, the linseed oil mixture, if not buffed thoroughly, can pull inside the texture grooves and cure into a sticky yellow film that's nearly impossible to remove without sanding. Wipe carefully and check your work in different lighting before you walk away. This is a great $1 fix for the right problem. It is not a miracle. Use it accordingly. Part 9. Closing the case. Pull back to that 7-year-old SUV in the driveway from the start of this video. The owner has 2 paths. Path 1, $385 at the detail shop. Beautiful for 30 days. Then back where they started, recurring every season for the rest of the time they own the vehicle. Over a decade, that path costs roughly $4,000 in compounding maintenance for a single cosmetic problem. Path 2, a $2 bottle of 70% isopropyl alcohol, a $1.50 bottle of mineral oil, a roll of painter's tape, 20 minutes of work in the driveway every couple of months. Over the same decade, that path costs roughly $40. Both paths end with black trim. The difference between them is not money. The difference is information. You now know what is actually happening at the molecular level on the surface of your bumper. You know why the expensive products fail, why the cheap solution works, where it will destroy your weather stripping if you are careless, and what to reach for when the damage is too far gone for the gentle approach. That is not a hack. That is literacy. The kind of literacy that used to be standard for anyone who maintained their own machines, before we collectively outsource that knowledge to the people who profit from us not having it. Take a walk around your vehicle this weekend. Find the chalky panels, tape off the rubber, spend 20 minutes and $3. Watch the color come back. And then take that mindset further. What else in your modern life have you been paying recurring fees to fix when the actual answer is sitting in a kitchen cabinet, unpatented and unmarketed, waiting to be noticed? The answers are out there. They are not hidden. They are just unprofitable to advertise. Stay sharp, stay self-reliant, and I will see you in the next one. This is Oracle Prime.